Hello, everyone. Hope you're all having a great time here at the Expo. Today, we're going to talk about how do we prepare for the next era of IoT connectivity, particularly from a cognitive IoT perspective. So my name is Veeru Ramaswamy. I run the Watson IoT platform business from all the way from product dev to the offering. And as part of the overall Watson and Cloud platform strategy that we have. And I can tell you IoT is one of the strategic imperatives of IBM, and which we believe is a growth segment for IBM. So we look at connectivity, which is the operative word here, as in 3 dimensions: devices, data, and decisions. Right? Think of 3D, simple to remember. So devices, data, and decisions are the key for your entire IoT strategy. The key part here is devices. If you're thinking only about connecting devices, that's simple. I mean, just like the previous speaker, people have been doing connecting devices all day long for 30 years. But it is how do you actually take the data and connect the data with multiple other sets of data. Then it becomes an interesting problem to solve. So that's what we believe, and that's what we believe in decisions to drive that particular insights. Yes, I think actionable insights is the wrong word to use, but actionable outcomes is a much better word to use for most of the IoT solutions. And I'm hoping I'm clicking the right button. OK. So at the heart of it, IoT is a data problem. Right? How do you actually bring not only your IoT data, which is the sensor data. By the way, when we say sensors, we have a wide range of sensors as opposed to GE. By the way, I was one of the first 2 people to be the start the GE Digital in San Ramon, California. So I understand from all the things which Robert was talking about. The key thing here is that we look at a whole range of spectrum of sensors. It could be simple pressure, temperature, humidity sensors. We think about myocardial, hemodynamic sensors. In the healthcare space, we think about sensors as even your microphones and cameras to capture your audio and video signals. So anything that captures a metric or a signal from the physical world and be able to transfer data to a digital world, we think that as a sensor in whatever form it is. Right? So now, what IBM research has found is that if you look at 90% of IoT data, it is not even sometimes discoverable. It is sitting in some silo, some server. And when I say unseeable, when we say unseeable, it doesn't mean we can't see it. You have to go and tap into those systems to get into those, get the data. And it is not discoverable by traditional computing systems like the cloud computing systems and so forth. Right? So the challenge is how do you get to the data, how do you get those data, and how do you actually get the data from your enterprise world, your operational world, and then be able to marry all of those to get the insights. And that's where we believe building horizontal applications over your platform would be extremely crucial. When we say horizontal applications, all the things we talk about, I mean, remote monitoring is one of the simplest horizontal applications, which can be applied across any different industry, right? Think about, I mean, asset management, predictive maintenance, operations optimization, whether it's your field service operations, your customer service operations, whatever operations you have. But all of the data which you collect from your operations and from your IoT and then derive insights would have a much better impact. So that's what we are going to talk about next. And how do you build these horizontal application layers on top of your platform is going to be crucial. So let's see how do we leverage the IoT platform, right, to connect all your devices, data, and information. Of course, the very first thing on your platform is how do you connect and manage seamlessly. This is going to be the key for the adoption of any IoT platform. It's very basic foundational, but this has to be done in a very effective manner. If it takes more than a minute or 2 for your devices to get connected to the platform, the developer is not going to have a pleasant experience. So how do you actually make sure that it is extremely easy to connect, fast, near real time, and that's where it's going to be very effective. The other part is how do you actually create a central hub in your platform strategy, which means how do you actually enable developers to go and connect the devices seamlessly by providing access to all the catalog of devices that can actually connect to your platform. And this is a very tough problem because now we have to work with multiple of the actual manufacturers, OEMs, and so forth to establish an ecosystem. And we'll talk about that later, but that's one of the crucial aspects of how you actually scale the platform. The second thing is speed to execution. When you actually build application solutions, when the developers go and build application solutions, they want to see that they can build application and services really fast, which means you have to provide all your breadth of services, which could be data, cognitive, AI and machine learning services, et cetera, all of this should be provided to the developer at a much easier manner rather than them trying to figure out how do you actually build. We'll talk about what we do in Watson later. Then, if you're able to do this, if you're able to provide a delightful user experience, then you will see your adoption of the platform in a much larger scale. So that's what drives the adoption scale. It is easy to build very siloed solutions, but if you have to scale horizontally across multiple different industrial verticals or consumer verticals, it's going to be extremely difficult without this adoption at scale. The next thing is, what do you get? Okay, you got adoption at scale, then what do you do with it, right? Then you look at all the data that's going to come through your platform. And that's where it becomes very, very interesting. And sometimes it's painful to say, but if you look at what Alexa has done from Amazon perspective, it's something phenomenal, what they have accomplished using skill kits and all of that. So to get that kind of a usability perspective, you have to be able to build your platform that can be easily consumed and easily be able to provide the user with a better experience. And then from the data which you collect, you can derive a lot of insights with multiple, from descriptive analytics to all the way from predictive prescriptive analytics and insights, right? And that's where it really drives actionable outcomes and not just insights. And then that drives you to accelerated growth and revenue. So this is how we think about how we actually go about building platforms and solutions. And this is how we are saying that makes a lot of difference when you actually scale your platform. So let's look at some of the essential components of what we have, both from a Watson IoT perspective and in general, should any company or business that wants to build IoT platforms, right? Connection messaging, so think about all the protocols you want to support. You want to be able to support all your HTTPS, MQTT, CoAP, all of the other protocols that gives you the messaging, enable the messaging to go from devices to your platform. And then you also want to be able to not only just worry about your devices and your cloud platform, but you also have a variety of things that you have to worry about. You have to worry about things such as, are you going across gateways? Or do you have popularly called edge computing, but edge computing has been there for quite a while in other areas of business as well. If you have done CDNs and things like that, there's the edge servers which are streaming all the time. So edge computing is not something new, but it's new to this part of the IoT world. And then talk about the network service, right? Some of these engines and turbines, if you look at, are sitting in some remote areas. Wind turbines will be located in some part of the corner of the world where the connectivity is a huge problem. So what are you actually doing to make sure the connectivity is as simple as possible when people want to build application services on a platform? So that's going to be the key. So there are multiple 5Gs tackling some of these problems in the wireless world. There is LoRa, Sigfox, all of these, which are also tackling some of the problems in terms of connectivity. So you have to start looking at much more deeper when you start building your platform. One of the biggest hurdles IBM research found, and also one of the biggest hurdles that the analyst community has found, is that security is the biggest hurdle for most of the adopters. 48 to 50% of the people who wants to do IoT are extremely scared because of security, whether it's going to get compromised, whether their enterprise systems are going to get compromised, and so forth. So how do you actually manage security? We have a complete risk management portfolio where we address security all the way from the bits and bytes level using TLS, X.509, and so forth, all the way to the application stack. So we have a variety of layers where we tackle security in our Watson platform. And this is something very fundamental. How do you actually get not only your IoT data, as I said before, but get enterprise data, operational data from your business decision support systems, operation support systems, et cetera. And how do you collect the data together, both from structured and unstructured perspective? How do you actually get the data to be able to ingest, collect, store, transform, analyze? How do you organize the whole thing is going to be very, very crucial. So the kinds of database services and so forth that you want to choose is going to be extremely crucial. And once you get the data, you actually start looking at what kind of analytical models that you want to build on. We have a suite of analytical models which we support in Watson APIs. And then we also have what we call the data science experience for developers, where they can actually take these models and plug it in directly on our data platform, so the Watson data platform. So I think those are some of the crucial things we do and makes it easier for developer community to actually go and start building application services. So this concept of edge computing is, as I said, not pretty new, but it's new for the IoT world. But the concept is that we believe can be as small as a Raspberry Pi board, which is just a 128 MB RAM, or it could be 1U, 2U chassis sitting on your data centers, right? So there's a whole breadth of services. But the key concept here is how do you actually distribute your workload? Particularly when you're saying you're going to scale to 50 billion devices in 2020, which is the normal number everybody's talking about. How do you scale? So if you want to scale, so obviously you want to tackle some of the compute, store, and analytics closer to the asset, which is the edge. And how do you do that? So we believe in how do you distribute the workload, how do you actually have the edge working still when there's limited connectivity or disconnected from your cloud platforms, and how do you take that as an extension to the cloud rather than as separate edge compute closer to the asset. There are many things we're looking at. We're looking at how do we actually build the analytical models in the cloud, but be able to push the models closer to the edge so that the insights are triggered as soon as the data comes in from the assets. And so whatever the outcome is, whatever action that needs to be taken upon, people can do it much faster, particularly for mission-critical systems. And then how do we actually support the developer tools? So we have something called Node-RED, which is a Node.js environment, where we actually enable simple plug-and-play development by just clicking and dropping modules, and you can build application services. So a remote monitoring application is just very easy to build within less than half a day, right? And I've seen many of the other applications going through such kinds of build. And the other thing is what kind of user experience you have. Are you providing enough business insights, and are you providing enough user interfaces that are easily consumable, from charts to trends and so on and so forth? That something which we have already integrated into the platform. So talking about the ecosystem, right? This is not easy to build unless you have a very nice ecosystem to build upon. We call from chip to the cloud. So we start all the way from the silicon, right? And we have silicon providers where we have partnership with. And then we have work with the ODMs, the original device manufacturers, who actually embed these sensors. And we work with them to say, what is the connectivity and security mechanisms that they need to have so that off the shelf they can start plugging into our platforms. The second thing is gateways. So gateways is not something as simple as just routing your data or just, having a firewall to pass the data through certain security and so forth. But gateways can actually become a source of your compute, store, and analytics, or can become an edge platform if you rightly architect your edge computing in that gateway. So we have many partners we work with on the gateway side as well. And as I said, the network is going to be a crucial component where you actually start working with the network service providers like AT&T, and they are very closely partnered with both on security and also on the node development. And how do you actually then scale it to the cloud, our IBM cloud platform, and the solutions and applications on top of that. So this is the end-to-end story in IoT, for instance. And this is not going to be dominated by one provider anytime soon. This is going to be a complete partnership with multiple players involved to make this story successful. So now let's look at what are the application services that you need. And when I say connections are missing here, what do you need to do to make sure that the IoT story is a successful story? We have customers on aviation, transportation, oil and gas, healthcare, and so forth. We have worked closely with our customers to make sure the kinds of instances they need, whether they need public instances, dedicated instances, or on-prem instances. And we have worked closely with them to make sure the actual product and service offerings that they have are being addressed. And we also look at what kind of gaps they have so that we can leverage from our IoT platforms with their product and service and offerings and be able to better address the market. And the key aspect is also, one of the things that we want to look at is, most of these, if you look from industrial side, is managed service agreements or service level agreements. How can you actually better improve their offerings to manage their warranties and service offerings is a key aspect which we find from all our customers. So helping them in those aspects would be extremely crucial for us. So let's look at one example of a smart building provider who builds elevators and escalators. The customer is Kone, and let's roll that video.
So what we do is we provide people flow. We help people move in and between buildings in the smoothest and safest way. Globally, we service more than 1.1 million elevators and escalators. We move more than 1 billion people every day. If the equipment that we service are not operating, we have a very significant impact on the way cities work. People may not get to their work in an office building, or people may have difficulties getting to their home. We have many different types of customers. We serve construction companies, builders, developers, building owners, and the expectations of our customers are increasing all the time. They are expecting an uptime that is constant. They are expecting transparency and predictability of what we do. With Internet of Things, we're going to be able to provide totally new types of services to our customers. We looked at the whole market and quickly realized that IBM is clearly a leader in IoT and cognitive analytics. We are using Watson IoT and its cognitive capabilities in many different ways. We can predict the condition of the elevator or escalator, and that way help our customers manage their equipment over the life cycle in a much better way. They are not going to have surprises. Watson IoT is helping our field technicians troubleshoot problems. So when they face a problem they may not have seen before, Watson can give them advisory and that way have equipment up and running in a much faster time than before. We are also using IBM Watson to help our call center technicians perform their job. And what is great with IBM Watson, that it learns all the time. The more it sees situation, the more intelligent it becomes. Our customers no longer want to buy product features. They want to buy outcomes. What I think is the most exciting is that we can provide individualized services that specifically meet the needs of our customers. It is no longer so that everyone has to get the same things. Now our customers will get services and outcomes that fit their exact needs.
So that's one example in our smart building escalators, elevator space, right? So another customer story is mining. These are some of the harsh conditions, just like in oil and gas. These are very, very harsh conditions where we want to be able to bring efficiencies in their annualized savings. So what we did was, it's not just about how we connect the data, the machines, and then get the data from those machines. We also started to integrate weather data, which we acquired, IBM acquired, by the way, a couple of years ago, and then started integrating that data with IoT data and did analytics on top of that to do predictive maintenance of these particular. So think about when the weather is bad, all your equipment is inside. That's the best time to do your maintenance rather than when you're actually working on the mining field, right? So we were able to take the data and be able to predict when should they be actually doing predictive maintenance. The second thing we also did was, how can we order these parts and things like that from a supply chain perspective, and how to manage their entire operation using the weather data and the conditions of the equipment. So this is another example where we worked very closely with some of the mining companies, and we were able to build some real cost savings on their bottom line. Transportation is one of the most potential industrial segment where this disruption can happen, and it's already happening in some space. This was happening from my G days and from here in IBM. We are working with some of the largest railways in Europe, and we have all the doors in the railways on their cars are being connected to our IoT platform, and we're able to manage the inflow and outflow of the people that enter into the train cars and out. So the key idea here is you think about passengers, passenger safety or passenger convenience. When you know how many people are entering, you can set the temperature accordingly by the driver or remotely. And think about when we get the data from these train tracks when they're overheated, when you actually be able to reduce the speed and make sure the trains don't go off the rail, and then be able to manage the actual speed of the trains itself. So things like that we have done. And there are examples in other cases where it's an interesting example in the sense that there are a lot of sensors on the wheels of the trains. We used to collect data from there and be able to maintain these wheels from a problem called flat spotting, which is similar to what happens in your car tires, right? So the data that actually gets that from these wheels, you can actually be able to, they'll have to shave the rim of the wheel and then be able to use it again. And so some of these aspects we found were extremely interesting examples that we were able to address. And think of the time where, suppose the door gets jammed, the data which we have from the trains can be sent over to the maintenance folks a priori, so that the maintenance folks doesn't have to be waiting for the trains to come in and start working. They know what parts to be ordered or what parts need to be fixed and so on and so forth. So that's something which we are working with one of the largest railways in Europe. So in fact, the maintenance cost is something which we had a 10x savings for them on the tracks and trains. This is another very potential example where airplanes are one of the most complex machines that mankind has ever invented, I would think. The engines has thousands of sensors, as the previous speaker was talking about. And the amount of with that sensor information, you can actually tap into every maintenance that goes through, looks for all these alerts from these engines, and then be able to have an unscheduled, instead of an unscheduled maintenance, you want to have a maintenance where it's properly scheduled, be able to predict what those alerts are actually going to say. Usually it's the analytics that derive from those are based upon things such as thresholding techniques, but we have now started to look into advanced analytic models into those kinds of alerts. The other area where we are found, because here's the potential for thousands of sensors on the plane, other area where we are closely tied is we take the data with the weather data and the turbulence information that is on board and be able to address the pilots, the dispatcher can address the pilots to say, take a different route because of the turbulence which is happening because of the weather, or they could actually take that information, the turbulence information from one of the planes and be able to pass it on to the other planes so that they do not get affected by turbulence and they can reroute that information. So we have some of the airlines closely working with us on that aspect as well. Here's another example, which is a cool example, I would say, outside of the industrial segment. We are working closely with the USA cycling team to optimize the performance of the cycling team. So we collect data from the wheels of the cyclists. We have sensors on cyclists, and we have dashboard video that collects information from a visualization perspective. And then the coach can actually look into that information and say, what power does the athlete have today to make the difference between a gold winner and a contender, right? And what kind of oxygenation levels that he has so that he's able to generate that power. And look at the lap timing and so forth. So let's roll that and see what happens. So those are some of the customer stories we have today. And what's next in IoT connectivity, right? That's the key question everybody's asking today. I mean, everybody knows to connect devices, everybody knows to attach things, everybody knows how to monitor assets, et cetera. We believe the next disruption could actually come from logistics, and blockchain going to be a bigger part of that equation, along with all the IoT data that we have. So that's something which we are looking very closely. The warranty and service contracts, which we talked about before, is going to become more environmentally aware, contextually aware. So the SLAs and MSAs you're signing today would not be a very blatant agreements, but it will be driven by these kinds of conditions. And the data that you collect is going to be used to show what kind of agreements are going to be useful. And lastly, everything which we see in homes today is going, like the smart thermostats and smart carbon monoxide monitors and all the other devices we are seeing today in the home, we expect that to see in retail and hospital and office spaces. So that's our prediction, and we'll have to see what happens in a year from now. So the challenge for IoT is not in the device connectivity. It is how you connect the data across your enterprise, how you bring decisions across your enterprise, and be able to connect these smart products and smart services. And that's where you will find most of the value by building application services on these enterprise decision systems. Thank you.